So hi everyone, welcome again to my YouTube channel Fitness Fit Code Geek. So how are you all doing? So in the last lecture, I have given you some coding example on pointers, where I have shown you how pointers work. Actually how you can practically do a programming on pointers. Okay, where I have shown you some really basic example. Okay, so I hope after the previous lecture, your concept of pointers are more cemented in your brain. So let me in this lecture I will show you some most important part of pointers here. Okay, most important thing about pointers which we should learn. So basically, whatever I teach in this lecture will be beneficial in the most important part of coding, that is data structures, where you will find the most application of this part, where which I will teach today. Okay, so today's topic is arrays and pointers. So you might have seen my arrays lecture, or you might have learned from anywhere else. So if you want to learn array from my lectures, you can go back to my playlist and check out that video. Or if you just have learned somewhere else, so it is also good, whatever you like. So these two are really the most important thing. These two are really connected to each other. So without wasting any time, let's now begin it. Let's open my PowerPoint slides. So pointers, guys, if you remember this point, it is very essential. You are seeing this in logo from starting of this lecture. Okay, so now pointers and array. So let me show you that. So if you remember array, how you used to daily declare array. So suppose that array of 5 element. So how you used to define this array? 5. So remember that indexing an array always begin with 0. So first index will be 0, second will be 1. So this is array. You all know this, and I am just revising here. Okay, so that it will be very clear when I will go depth of this topic. Okay, so what is array A of 0? It is the first element. What was array of 1? It means we are at location second, an array of second, array of third, and array of fourth. Suppose this array contains some elements like suppose that 21, 18 something. So these are elements. So the A of 0 means 21, A of 1 is 18, A of 2 is 64, A of 3 is 52, and A of 4 is 1. So this is the basic way we assess the element of the array. Remember that array is continuous block. Okay, these are the basic points you should remember before going into this. So you know that array is continuous block of memory. Okay, always continuous. You know that the array is always a continuous block of memory actually. So whatever you declare, suppose array of 5. So if we add suppose that your architecture is following x 64, and it will give an int as 2 bytes, suppose. So suppose that first index is 100. You already know this part, in array lecture. Okay, we discuss it there. And so second will be 102, and this will be the address of this array. So what's this address? These are continuous block actually. So you might say that 100 and 102, why you write that? If you watch my array lecture, you find that 2 blocks are considered because 2 bytes. So each block of 8 byte, 2 byte will be considered actually. So 2 byte will be considered 1 byte because it's integer type array. So that is the case. So in this way, the addressing are in continuous block. So this will be helpful in understanding the arrays and pointers here. Okay, so let me just show you some point. So in C there is a strong relationship between pointers and array, strong enough that pointer and array could be discussed simultaneously. So this point is very important. That actually in C, strong relationship between arrays and pointer. Okay, so arrays and pointer are strongly related. They can be used interchangeably sometime. So what does this statement mean actually? I will get into that I will learn from the points also, but let me just show you. So suppose the same example, int A. So array of what does this mean? What do this actually mean? I am not gone into detail in fact. I have told you that we will deal with array in pointers. Okay, hope you remember that lecture. Okay, so what is this? This is actually mnemonic. You know what is mnemonic mean? It is actually mnemonic. So it's actually mean if you have used array in pointers, so we just pass the name of this part. Okay, so A itself is a pointer. Okay, so this is the very most important thing which will be useful in any part. Okay, this is a property that array itself is a pointer. It's not a normal variable. A of 6 is just, a is of course a variable, but when you attach this parenthesis with and assign some element, it's become a pointer actually. Okay, so a is a pointer. So if you, I will just discuss this coding example. You will learn more about this when I show you the coding example in the next lecture, upcoming lecture. So but from now, just think about this. So what could be the, so if array is pointers, and it will follow all the property of pointers. Okay, it is not follow some of the property which which I will show you later. But a will have, so address of a is similar to, means and a is also, the suppose the address is start with 100, this will be 102. What I mean to say here is that value of a is similar to a of 0 actually. Okay, quite interesting. We will also understand that pointers, if I define pointers, suppose int star p, so it will, if I address this, assign the value of a like this, or simply if I make this as a, or p equal to a something. Okay, anything. I will go into coding part later, but just imagine that if I do like this, so p can be also used as, is value of p will be of course possible. You can also use that p of 0 also. Okay, so these are interchangeably, they are used interchangeably. So array is internally actually pointer. Okay, remember this. Starting address, the the variable used in to define an array is actually pointer. You can say that intuition may have told you that pointers are different and array are different because we are using different notation here. So we are using different notation here, but actually these two are very much same thing. Okay, or you can also write it, there is one more way I will show you here, that address of a is similar to a plus 0, because 0th index, it refer to 0th index actually. So a of 0, so value at a of 0. Yeah, similarly value of a is like that, and the value of a plus 1 will be what? You have to use the bracket here carefully. You know from the pointer arithmetic that if I use just value of a plus a, then it will increment the address of a. So it can be also done. Yeah, these two, let me, I will show you in the code part what is the difference between this and this. Okay, if I write this or and this, what is the difference here? So array of 1, it can be written as a of 1. Okay, you're getting it. Same thing can be done with a p also. Okay, p variable, value at p of 1, p plus 1, p of 1. Okay, remember this point, these are very important. Okay, so with this intro, let me show you the points. Okay, hope it is clear to you guys. Okay, these, remember that the only thing you have to remember and not remember, understand that both the pointers and array are actually arrays are actually pointer internally are pointers. Okay, there is nothing much more difference, but there is one difference. Okay, there are 2 to 3 differences which I will show you what could be difference. Okay, in upcoming slides. Okay, so now moving on. So let me show you the point here. Okay, any operation that can be achieved by array subscription can also be done by pointer. So I have shown you that any operation that could be done in array can also be done with pointers. Okay, remember this point. It will be much clear when I will show you the coding part. Okay, just wait for it. If you don't get that theoretically, we are not able to think and develop your logic here. Through practical example on coding, it will be clear. Okay, so you can develop your intuition that an array operation that can be achieved by array can also be done by pointer, which I have shown you that so which I have shown in a lecture that if you write a of 0, you can, if you declare one variable pointer variable p, you can also write p of 0. Okay, so a is actually pointer, and if you declare int p here, will just and make assign to a, you don't need to use here ampersand. You can directly assign it here because a is internally a pointer, so it will just point to the first element of array. Okay, if this continuous block of array, p will point to the first element, and incrementing p will point to p to this part. Okay, and p will now point to second element in that way. So, and it can be also done with a also. Okay, I will show you some of the things. It cannot be done with a, so some operation are not used. Okay, operation that can be achieved by array, so these have some exception which I will show you. Not only always true, but some of the operation you can use interchangeably. Okay, which I have shown you. Okay, now moving on. The correspondence between indexing and pointer arithmetic is very close. By definition, the value of a variable or expression of type array is address of the element 0 of the pointer. So what I have told you, that if you declare array, okay, array A, this is array, declaring pointer is suppose int p assigning to a, same as p is value of p will be is equal to a of 0 actually, and value of p plus 1 will be a of 1. So in this way it will work actually. So what let this line say that the value of a variable or expression of type array is the address of element 0 of the array. Okay, the value of a variable or expression of type array is address of element 0 of the array. Okay, so hope you're getting it. Now let me show you the next point. Hope it is clear to you guys. Okay, the pointer variable is just point to the first element. Okay, so now moving on. The name of an array is synonyms for the location of initial element. What I have told you. Okay, so already so A is actually the initial element. Okay, so it will point to, suppose the element start with 100, so A will just will 100. So it is used as interchangeably. So one more application is if you declare one pointer here. Okay, so if you calling function, right, something like sum, and you want to pass an array, so you just pass the initial address of the array. Means suppose you declare array int A5 or something. So you just have to pass the starting element where you will find this application. Okay, you can just pass the starting element here. Okay, this will location of the initial element. It will, so if you pass it, so it is actually become like this. Okay, or you can pass the pointers also. Okay, if you declare int p here, you can declare the pointer also. It will behave as same because according to this property. Okay, so hope it is clear to you guys. It will more clear in when I am going to coding lecture, but you can develop your intuition from here. Okay, now let me see the next if there is one. Okay, now let evaluating a of I, c converted to a of I, which I have already told you that how it will work. C converted to a of I. Okay, a of I actually this mean automatically it is done internally. Okay, or both are form are equivalent, and applying the operator and to both part of to the both part of this equivalence, it followed that address of a of I and a of I are also identical. Okay, so it will be clear when I will show you the coding part. I just want to develop your intuition here. I will definitely show you giving the coding example, because more thing you learn from code. Okay, you can see the practical live example from here, but that's how the people can develop intuition from it here also. Okay, so if you understand it mathematically from here, it's like a logic, then coding part will be much easier. And if you don't worry that if you are not getting it from the theory part, you will definitely learn from the coding part. Okay, so what I was trying to say, applying the operator of AND means address of a of I is similar to a of I, and a of I already told you is similar to value of a of I, which I have shown you that. Okay, it's very simple logical thing. Okay, because array is continuous block of memory, so each element increment will increment the value. Now let me see the next point. So as the other side of this coin, okay, so if you can also value, I have told shown you. Okay, p of I, you can write it like this. So it's a very fascinating thing. Just declare one variable, so p, and assign it to p. Now it behave like an array. Amazing thing is you can see that. So this is the power of pointer. You can also see the power of pointer here. Just a variable, and it can point to just starting element, and by pointing to starting element, it can go to other element, constituent element of it. Okay, because of randomness property of array. Okay, so you must understand it here. Okay, so now let me show you next point. To insert an array, an index expression is equivalent to one return pointer upset. Okay, so hope this point is clear to you. So this is a remark which I am talking about. Then remember this point. Okay, just important. A pointer is a variable, so you can write pointer is a variable. Okay, so you can now, after coming to this, you might have developed the intention that whatever operation can be done in pointer can also be done by array. Yeah, it's possible, but not in all the cases. Okay, so pointer perform more operation than array. So but array is not a variable, it's just a mnemonic. Okay, mnemonic and variable are different thing. So you cannot write this, you cannot assign a to p. Okay, you might be argue with me that if a is pointer, then I can assign it pointer, because assigning a work in pointer, we have seen the pointer arithmetic here already in the last previous lecture, but it cannot be done. Okay, it's not allowed. A plus plus cannot also be not be done, which we have talking about in the first slide. Okay, so these two cases you must remember this part. Okay, so you can behave both, means if you want me to draw a Venn diagram, so what you could say, you can understand from Venn diagram. So which one is which? So so every array is pointer. Okay, and any operation, so operation wise, suppose so any operation which can be done on array can also be done in pointers. Okay, a sum of the operation like a equal to p, it cannot be done. So pointer will be this part. Okay, so array is actually smaller than pointer. Some of restricted operation are there in array. So array is actually a pointer also. Okay, but there are some restriction on that. So which can be clear from this Venn diagram. Okay, understand that means sum of the intersection part is not is equal to 5. In some part here is add operation which can be done by pointers variable and which cannot be done by array operation. Okay, but all the operation that can be done in pointer array can also be done in pointer variable. Okay, so this hope this Venn diagram is clear to you guys. So now moving on. So that's all for today, guys. So it's very short lecture. I've just made it short so that you can just go through the lecture 2 to 3 times and you understand all the concept here. And in next lecture, I will show you the coding part. Okay. So I'm going very slowly here. Okay. I'm not putting all the if I just put all the coding part is there also, it will be confusing to you, cumbersome to you. So better just go through the theory and analyze it, develop your intuition. If you are not able to develop it, please write in the comment box. And also you can wait for the next lecture when it will release. I will show you the coding part. Okay, you will understand it better here. So thanks for watching. See you soon. Take care.